Hello everyone. Welcome to my channel Behind the Binary. In this lecture I'm going to discuss about Python NumPy and Pandas. Install the required library NumPy. Pip install NumPy. Then import NumPy as np. I'm taking a sample list of 1, 2, 3, 4, 5 and adding it to np.array, then printing the output to check how the output is coming. Also printing the type to check what type it is. NumPy, numerical Python, is a core library in Python used for scientific computing and efficient numerical operations on large datasets. It provides support for multi-dimensional arrays and mathematical functions that operate on these arrays. Let's see the output, how it is working. You can now see the output type of array and array. Let's explore more with 2D array. A two-dimensional array is added to mylist2. Let's see how it will take into np.array. A 2D array in NumPy is essentially a matrix, a table of elements with rows and columns. It's an array with two dimensions, where each element is identified by two indices, row, column. Use cases of 2D arrays. Matrices in linear algebra. Images, grayscale. Tables of data before loading into DataFrames. Grids in simulations and games, example, chessboard. Now you can see that is printing 2D array and its type. Let's explore arrange in NP array. How it will arrange the array with given inputs. Passing starting point as 0 and ending point as 10. We can look later what is third parameter. The third parameter is used to skip the values by the step with given input value. Printing to see how arrange is working, and checking its type. Let's see the output now in output window. You can see the output is printing the values starting 0 to 9 because we have given start index is 0 and count is 10, so which is arranging the values like that. Now let's see by adding third parameter which step each value after every value. Let's have a look for NumPy operations in Python, like zeros and ones. In the output, you can check which is printing the zeros and 1 with given range of 3 rows and 4 columns. Now let's see addition, multiplication, subtraction, and division. Taking a sample values of array in a variable to check operations. Calling all the methods like add, sub, mul, and div and printing its output. Trying to show how it will work for all these operations. NumPy, operations like add, mul, multiply, div, divide, and sub, subtract, are element-wise arithmetic operations you can perform on arrays. These operations apply to each element individually and return a new array. NumPy operations are fast and efficient because they operate at a low level in C and avoid explicit Python loops. Broadcasting allows NumPy to perform arithmetic operations on arrays of different shapes by stretching the smaller array along the missing dimensions without copying data. NumPy supports element-wise arithmetic operations on arrays. Element-wise means the operation is applied individually to each corresponding element of the arrays. We can see the output is adding, subtracting, and multiplying the values in the given array. In the given array, we can also perform division. Let's check in the output how it performs division. You can check the output now how it is working. Within the given input, np.divide is performing division for each column. Let's explore more operations like sum and min and max. np.sum calculates the sum of all elements in an array, or along a specific axis, row-wise or column-wise. Very useful to quickly add up values. np.min finds the minimum value in the entire array, or along a given axis. Important notes. The axis parameter specifies which dimension to operate along. Axis equals 0, operate down the rows, column-wise. Axis equals 1, operate across the columns, row-wise. If no axis is specified, the function acts on the flattened array, all elements. In the output, you can check the result for sum, min, and max. We can also check the size of array. .size, total number of elements in the array. The .size attribute returns the total count of elements in the entire array, regardless of its shape. .shape, shape, dimensions of the array. .shape returns a tuple representing the dimensions of the array, number of elements in each axis. We can now see the output how it is printing the size. Now let's explore about Python Pandas library most useful series and data frame. A series is a one-dimensional labeled array capable of holding any data type. A data frame is a two-dimensional table, like a spreadsheet, made up of multiple series, columns. am taking a sample data to a variable to check how series works. A Pandas series is a one-dimensional labeled array that can hold data of any type, integers, strings, floats, Python objects, etc. It is similar to a column in a spreadsheet or SQL table, or a dictionary with index labels. am taking the index values to add to series. In Pandas, the index of a series is like a set of labels or keys that identify each element in the series, similar to row labels in a table or keys in a dictionary. Why is index important? Helps you locate, retrieve, and filter data. Supports label-based operations, like .lock. Allows for alignment during operations, e.g., addition, joins. Makes data more readable and meaningful. Let's check the output. When you create a Pandas series, you can optionally specify an index, which acts as labels for each data value. By default, Pandas assigns integer index values, 0, 1, 2, but you can assign custom labels such as strings, dates, or other values. Adding a custom index makes your data more readable and meaningful. Allows for label-based data access, not just position-based. Is especially helpful in real-world datasets where rows represent named entities, like dates, product names, or IDs. Let's have a look for data frames. A data frame is a two-dimensional labeled data structure in Pandas. Think of it like an Excel spreadsheet, a SQL table, or a dictionary of series objects, columns. Key characteristics are likely 2D structure with labeled axes. Each column can have a different data type. Rows, index, and columns, headers, are labeled, fast and efficient for large datasets. Use cases: data analysis and exploration, data cleaning and transformation, data visualization, with libraries like matplotlib/seaborn, machine learning input, output, exporting to CSV, Excel, databases. Also, we can import or export from JSON. I have a file named names.csv here. I'm trying to import it using Pandas. Let's see in the output how CSV is get imported to variable. CSV, comma-separated values, is a common format for storing tabular data. You can easily import a CSV file into a Pandas DataFrame using the read_CSV function. Using head and tail functions, we can get first 5 rows and last 5 rows in DataFrame. In the output you see it is extracting first 5 rows when we use head function. Head and tail are two convenient functions in Pandas that help you quickly view the first or last few rows of a data frame or series. Trying to increase the sample data to understand it clearly. Head, quickly preview the start of data. Tail, check the most recent or last rows. Both validate that CSV or data load worked properly. Helps verify. Column names, data types, missing values, extra metadata in last rows, like summaries. Adding tail function also to check how it works. Let's see in the output. In the output you can now see it is brining first 5 rows for head function and last 5 rows for tail function. We can also check the index of dataframe and columns of dataframe and adding them into output. Let's explore the output window to understand how it works. A Pandas dataframe is a 2D table where columns are the vertical headings, like in Excel. Index is the label assigned to each row, the leftmost par. The index is like the row labels of a dataframe. It uniquely identifies each row. By default, it's a sequence of integers starting from 0. It helps you select, filter, and align data easily. The columns are the labels for each vertical slice of the data frame. Each column represents a variable/feature. In the next lecture, let's explore what is machine learning and its concepts and the data is feeded. Thanks for watching my video. If you like my video, share and subscribe to my channel.